All right, let's take a look at the periodic table of elements. So the periodic table is a table of all the different elements that are in our universe in existence. So this is a periodic table. Now, something like this is provided in your GCSE exam, so you do not need to memorize the different elements. I repeat, you do not need to memorize them. And this periodic table tells you about all the different elements that are in existence. And this specific table is from AQA, so if your exam board is AQA, you'll get something similar to this. If it's at Excel, you'll get something similar to this, so on and so forth. Anyways, so in this video, we're going to look at how the different elements are arranged in the periodic table. And more specifically, they're arranged in rows called groups and periods. So we'll look at what groups and periods are. And each of these groups, some of these groups have different nicknames. So halogens, noble gases, and alkali metals. So we'll look at a bit into this as well today. So first of all, the periodic table of elements. This was created by a man called Dmitry Mendeleev in the mid-19th century. So a long time ago. So in the 19th century, this guy called Dmitry made this periodic table. And what's really cool is pretty much what he made in the 19th century is what we still use to this day. And what was so special about it is that when he created it, he even left spaces. He predicted new elements that would be created in the future, and he left out spaces so that they could be filled in as they are discovered. So that's quite cool, right? And everything in the universe is made from these elements. So you could combine, so you could have a chemical bond and you could have a chemical reaction to bond these different elements together. And you could make kind of like different sort of elements, but they're combinations of elements. So they're not pure atoms. Each of them is pure cobalt, pure nickel, pure copper, right? It's not a mixture, or it's not a compound of different elements mixed together. These are just pure copper, cobalt, etc. And the thing is, the periodic table of elements, they are arranged in the order of increasing atomic number. So how is it arranged? It's arranged in the order of increasing atomic number. Now, what do I mean by atomic number? I drew a quick diagram here. So in the previous video, I took a look at atomic symbols and how the different elements are arranged in tiny boxes, right? So if we enlarge one of the boxes, so for example, hydrogen, it looks like this. The top number, watch the atomic symbol video if you didn't watch it, because that goes more in depth about this, but in summary, the top number, the smaller number, don't remember it as the top and smaller number, because sometimes it'll be flipped. So boron will have 5 on top and 11 on bottom, so it can be flipped. So the bigger number, so you can always remember it as a bigger number because every element, I chose hydrogen for a reason, every element but hydrogen has a bigger number. 16 to 8, 32 to 16, 79 to 34, 190 to 76. But hydrogen is the only element where the mass number and the atomic number is identical. Do you know why? I'll go into that in a second. So the top number in our example, so theoretically this would be the bigger number. This is the mass number, and it's the neutrons plus the protons. That's why it's bigger. Because the number of neutrons plus the protons, it has to be bigger, right? Because it's two things added together. So that's the mass number. Now the bottom number, the smaller number, tells us the atomic number, and it's the number of protons. So if you want to calculate the number of neutrons, you just minus the mass number from the number of protons. But think about it. If you minus 1 from 1, you get 0, right? So does hydrogen have 0 neutrons? Yes, it does. Hydrogen has no neutrons. So that's why I chose this example. Hydrogen is the only element with no neutrons. And that's why the mass number and atomic number is identical. But for all other elements, the mass number is always bigger than the atomic number because it's neutrons plus the protons. And atomic number is just protons. That's why it's also called the atomic proton number in brackets, because it tells us the number of protons. Now, the number of protons is equal to the number of electrons. So hydrogen has one proton, 0 neutron, because 1 minus 1, and 1 electron. So the number of protons and the number of electrons are equal. But there's a catch. For it to be equal, the atom has to be not charged. So if it's charged, so you can either have a positive charge or a negative charge. I explained this in the previous video, but so atoms can have charges. If atoms want to have a full outer shell of electrons. Now, if atoms have a full outer shell of electrons, then they're stable. That's what they want to do. And until they do so, they're not stable. So this hydrogen only has 1 electron in its outermost shell because 1 tells us the number of electrons, right? So this hydrogen will try to bond with other atoms to have a full outer shell of electrons. I'm not going to go in depth about that today because that's explained in the other video, but anyways. So hydrogen wants to have a full outer shell and it receives electrons in order to have a full outer shell. And when it does, electrons are negatively charged, so it's going to have a net negative charge. So the number of electrons are not going to be equal to the number of protons because it's going to receive electrons. On the other way, the opposite can happen. So if fluorine has 9 atoms, right? The maximum you can have in a shell is 8 electrons. So it's going to get rid of 1. So it's going to have 1 fewer electron than protons, right? And usually it'd be the same. So then that means it's going to have a net positive charge because there are more positive protons than negative electrons. Anyways, that's something for another video. But anyways, so the number of electrons and protons are all equal in the periodic table because these atoms do not have charges. Until they have a charge, the number of protons and electrons are equal. So carbon has 6 protons, 6 electrons. Sulfur has 16 protons, 16 electrons. And to get the number of neutrons, you just minus 32 from 16. All right, that's done. So let's look at how they're arranged now. So the elements are arranged in the order of increasing atomic number. Remember, the atomic number is the smaller number, just the number of protons. So if you look at it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So a new row is created every time every time the atomic number changes. So 1, 2, 3, 4, 5, 6. So it's kind of like in ascending order. 76, 77, it just continues all the way. So a new box is created every time there's a different number of protons. Do you know why that happens? Because the number of protons determines the element. So the number of electrons doesn't matter because you could have 8 electrons and 7 electrons, or it doesn't really matter. But the number of protons always determines the element. So any atom with 13 protons will always be aluminum. Anything with 31 protons will always be gallium, so on. Okay, so each group has similar properties. So by group, I mean this. Groups are the vertical numbers. So these. So there's a total of 8 groups. 1, 2, 3, 4, 5, 6, 7, 8. Now the last one is called group 0. I'll go into that in just a second. So group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 6, group 7, group 0. So each group is vertical. So this is all group 1. And if I can find another highlighter. Just a second. This is all group 0. This is all group 3, group 4, group 5, group 6, group 7, group 0. Now you might be wondering, what are these elements then? These are what is called the transition metals. These metals, so these have no group. They are not part of any group. They just exist there. Okay. And what's interesting, another interesting thing, is that there is a ladder. You could theoretically draw a ladder going from boron down 1, down 1, down 1, down 1, and ending at tennessine. So everything to the left of this arrow, these are all metals. And everything to the right of this arrow is a non-metal. I'm running out of space. So, metals and non-metals. So these are all non-metals. It's pretty obvious, right? Because carbon is a non-metal. Nitrogen's a non-metal. Oxygen's obviously not a metal. Helium's obviously non-metal. Hydrogen's also not a metal. But everything on the left side is a metal. So here we'll find stuff like copper, nickel, cobalt, iron. There's also gold and silver and sodium, potassium, everything here. So everything to the left of this staircase is a metal, and everything to the right is a non-metal. Okay, so I explained about groups, right? Groups are vertical columns going down, but these transition metals do not count as a group. They don't have groups. Now, what's so special about groups is each group has similar chemical properties. So group 1 has similar properties, group 2 has similar properties, group 3 has similar properties, group 4, 5, 6, 7, and 0, so on. Now, what these groups tell us is the number of electrons in the outermost shell of electrons. So if you forgot about electrons, atoms can have a maximum of 2 electrons in the first shell, and everything but this first shell can hold a maximum of 8. So everything past the first shell can hold a maximum of 8 shells. So group 1 has 1 valence electron. What a valence electron is, it's an electron in the outermost shell. So group 1, it has lithium has 3 electrons, right? So if we draw lithium here, it's going to have 2, and it's going to have 3. So the group number tells us the number of electrons in the outermost shell of the atom. Sodium we'll have Na, 1, 2, 8. So 8 plus 2 is 10, and 11 also has 1 electron. So all the atoms in group 1 have 1 electron in its outermost shell. All the atoms in group 2 have 2 electrons in the outermost shell. Group 3 have 3 electrons. Group 4, 4. Group 5, 5, and so on. You get it, right? Now, I don't mean they all have 1 electron in total, or 2 electrons in total. It means the number of electrons in their outermost shell. You see, the number of electrons are different. Lithium has 3 electrons, sodium has 11 electrons. The total number of electrons are different, but the number of electrons in their outermost shell is identical. Now, what about group 0 then? What this 0 means is that it means there's no electrons in their outermost shell. Look, helium has 2, right? Remember, the first shell can hold 2, so it has 2 out of 2 electrons. Neon has 10. First shell can hold 2, the second shell can hold 8, right? So 8 plus 2 is 10, full shell. Argon, 18. First shell can hold 2, second shell holds 8, third shell holds 8. 8 plus 8 plus 2 is 18. So all of the group 0 elements have a full outer shell. So they have 0 valence electrons. So what does it mean if you have a full outer shell? It means they're very stable and unreactive. So a key chemical property about valence electrons is that they're very unreactive and they don't really react with anything else. Now, each of these groups have nicknames. Group 1 is called the alkali metals. Group 7 is called the halogens, and group 0 is called the noble gases. I kind of find a good way to remember noble gases. They're so noble that they don't have any electrons helping them in their outermost shell. Don't know if that makes sense, but anyways. So group 1 is the alkali metals, group 7 is the halogens, and group 0 are the noble gases. Group 2 to 7, you don't really need to know much about their nicknames. So group 1, alkali metals, group 7, halogens, and group 0, noble gases. I'll go more in depth about all of these group 1, 7, and 0 elements because you kind of need to know them for your GCSEs. But that's pretty much all you have to do, all you have to know. So each group has similar chemical properties, and each group has the same number of electrons in their outermost shell of electrons. And that is pretty much all you have to know about the periodic table of elements. Oh yeah, I kind of forgot one thing. We explained groups and halogens and noble gases and alkali metals, right? But I forgot to mention periods. So groups are vertical, right? Periods are horizontal. You don't really need to know much about periods. It's just for knowing like the position. It's kind of like coordinates. You really need to know about the groups, but the periods don't really matter that much. But anyways, groups, vertical. This is the alkali metals. Group 7, halogens. Group 0, noble gases. And these are the periods going horizontally. And that should pretty much be it about the periodic table of elements. I hope this explains a bit about the periodic table. I'll see you guys in the next one.